Hi, fifth graders. This is Mrs. Copeland, and I'm a math teacher in Charlotte-Mecklenburg Schools. Today we're going to learn to graph changes over time. We will collect data that changes over time, we will represent data using a line graph, and we'll describe the data in a line graph. Let's begin by watching a short video.
La 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 la, hey ya hop, oh la 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 la.
Wow! Who knew we could waste that much water just brushing our teeth? I wonder if that's really true. Why don't we do an experiment to see? Most dentists recommend that we brush our teeth for 2 minutes. So let's do an experiment to see how much water we would waste in 2 minutes. I made a chart for us to track how much water we have wasted after 2 minutes. Since there are 60 seconds in 1 minute, we will follow this for 120 seconds because 60 plus 60 is 120. And we'll check every 10 seconds to see how much water we've wasted. Okay, are you ready? Okay, I've switched to locations where we have water now, and what we're going to do is every 10 seconds we're going to stop and measure to see how much water, and then we're going to figure out how much water we've wasted over time. Okay, we have 300, whoops, let me fix it where you can see it. I would say to the nearest quarter it's probably like 375, but we might say that's 380 because that's really closer to 400, isn't it? So 380 milliliters first round. Let's reset, try again. Oops. Ooh, 400. Looks like it's between 400 and 450, maybe a little bit more than 400. So we could say 410. Second round. Okay, third round, it looks like it's between 350 and 400, maybe like 375. Third round. Okay, now it looks like it's kind of close to 400 again, like really close. I would say, and it's between 350 and 400. So we want to say maybe 390. That was the fourth round. Oh, I didn't get it under there fast enough. It's hard doing this by myself. I need a team. Okay, now we see it's on, there's a bubble. It looks like it's right on 400, so we'll say 400. That was the fifth round. Okay, sixth round, it looks like it's right under 400. We might say 395. Okay, so for the 7th round, it's between 350 and 400, so we could say 375. Eighth round, looks like we're at a little bit over 400, maybe 410. Okay, and now on this round we have it looks like it's right at 400, so maybe 395. Can you see that? 395, it's just under 400. Okay, and this time we have 425. Whoops, let me put that where you can see it. Maybe 420. It's a little closer to 400, right? Halfway between 400 and 450 would be 425. So we'll say 420. Okay, ooh, this one, it looks like it's right on 400, doesn't it? Okay, so 400. I think we have one more round. Oh, now it looks like it might be just a tiny bit over, so we could say 405. Okay, let's move back and figure out how much water we just wasted. Okay, now our experiment is complete, and I have all of our data recorded here. What I did is I recorded the data, and then each time I added the new amount of water that was wasted. So 10 seconds has 380 milliliters, and 20 seconds I added the 410, so now we have 790 milliliters wasted. You can continue to see the totals for each time all the way up through 120 seconds. So I wonder what this information would look like in a graph. In 3rd grade, you learned how to graph categorical data, and you used a picture graph or you used a bar graph. Bar graphs are used for categorical data, so there's usually kinds of things. When we have a bar graph, you might be graphing, what's your favorite kind of ice cream? Or which subject do you like the most in school? Or what type of pet do you have? So the questions are different categories or different kinds when you use a bar graph or a pictograph. In 4th grade, you learned how to use a line plot. And for a line plot, the answers are always a number. So you might have questions like, how many children are in your family? Or, how many days were you absent this year? These are all types of questions that you might use if you were going to be creating a line plot. Now, today we want to see how a quantity changes over time. And if you want to see how a quantity changes over time, you might use what's called a line graph. We're going to be making a line graph today, so let's think about what's needed for a line graph. Let's use our data to make a graph. When we graph something that changes over time, we record the data on a coordinate system. We call this a line graph. One axis keeps track of the units of time, and the other axis keeps track of the amount being measured. The title of this graph tells us it shows us Kenya's savings for 7 weeks. It's important to have a good title for a line graph so that those who view the graph understand the type of data being shown. We see the time is marked on the horizontal axis known as the x-axis and labeled week. We see the amount of money that Kenya has saved labeled on the vertical axis and labeled savings in dollars. Then we see data points on the graph. We can see week 1, Kenya had about $12. Week 2, she had $50. Week 3, she had $75. And week 4, she had $100. And week 5, she still had $100. So she must not have earned more that week. Notice the data points are connected with lines. These lines show how the data is changing, and that's how this graph gets its name line graph. Hey, let's graph our wasted water data. We should remember to include the following: a title that clearly describes the information we are gathering, an x-axis labeled seconds and listing the time intervals at each tick mark, and a y-axis labeled milliliters and listing the quantities in milliliters. We'll also need graph paper. You can see I have our data recorded here for us to use when we're ready to make the graph. But before we begin making the graph, we need to make sure we have a few important things. For example, we need to make sure we have a good title on our graph. I'm going to use the amount of water wasted when we brush teeth. Now we also need to label our x-axis. And remember that we're going to include some type of time for a line graph. And since we were measuring in seconds, we'll put seconds at the bottom of our graph. It would be fine to just put the word seconds at the bottom. Now, let's see. We measured all the way from 10 to 120 seconds. So if I marked at each point on here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, my graph could only be used for 12 seconds. But I need to go all the way to 120 seconds. I'm wondering if I count by tens if that would work instead. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. That's good. I'm going to use that interval instead of counting by ones. This x-axis shows us our time in seconds. Remember, that's what's important for a line graph. Now I also need to get the vertical axis ready, the y-axis. I recorded my seconds on the x-axis, so what I'm going to do is record my milliliters on the y-axis. Now we go all the way up to 4,755 milliliters. There's no way that there's 4,000 lines there, so I'm going to have to think of a different scale. What if I were to do 250s, for example? So I could say 250 milliliters, 500 milliliters, 750 milliliters, 1,000 milliliters, 1,250, 1,500, 1,750, 2,000, 2,250, 2,500, 2,750, 3,000, 3,250, 3,500, 3,750, 4,000. Wow, so if I do by 250s and I count using that scale, I'm going to run out of space. So that's always important when you're making a line graph, that you think about what type of scale you might need to use. So 250s are not going to work for me. So maybe I'll try 500s. Okay, so what if I say 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, 4,500. Whoops, I got to go one more, right? And 5,000, and that would be enough. So I'm not going to use my whole graph, the top part, but if I count by 500s, then I'll be able to do that. And I should go ahead and write over here. Let me see if I can write sideways. And this is a tricky word to write too because there's lots of L's and I's. Milliliters. Okay. And I'm going to label by 500s because that will work for me. 1,000, 1,500, 2,000, 2,500, 3,000, whoops, 3,500, 4,000, 4,500, and 5,000. I really don't need to go higher, but I could if I wanted to. There's no reason why I couldn't keep counting up higher. But since I know my highest data point is under 5,000, I can just stop there. And I'm going to set this up here. Okay, so now we have our graph completely set up for us to start recording the data points. This is an important thing to notice about these, and I'm going to make sure, whoops, I just realized you cannot see all the way across the graph. There you go. Okay, so now I have my coordinate system, and see, here's 10, here's 500. So what I'm going to have to do is record the coordinates that I'm going to use. So the way I make my coordinates is I'm going to look at the time and the measurement. So I'll just write this one coordinate just so you can see. The x-axis, that would be the x for that one, is 10, and the y is 380. And see, I can write that just like you've been using coordinates on a coordinate grid, we can record coordinates on this line graph as well. So I have to go over 10, and then I'm going to go up to 380. And I don't have 380 marked over here because I had to count by 500s because my numbers were so big. So what I'm going to do, I know 250 would be right in the middle, right? So I'm going to go up just a little bit higher than that, and I'm going to mark my first coordinate. And then I'll look at my next coordinate. I'll do one more down here. And that one would be 20, 790. So I'm going to go over to 20, and I'm going to go up to 790. Again, 750 would be here, so I'm just going to go a tiny bit higher right there. All right, now I'm going to follow up here. Now I'll have 30, and then 1,165. We'll say about here. And then 40, 1,555. It's going to be just above that line probably. And then on the 50, I have 50, 1,955. It's almost at that line, very close. And then for 60 seconds, it would be 2,350, so a little bit above right there. For 70 seconds, it would be over to 70 and up to 200, 725. That's about in the middle. And 80 to 3,530. Whoops, I'm sorry, I looked at the wrong one. 80 is 3,135. So probably about here. 90 is 3,530. So it's going to be right over that 30 mark. 100 is going to be 3,950, so it'll be right under the 4,000 mark. And then 110 seconds will be 4,350. So we'll say about here. And I'm going to run into a little space. I'm just going to move over just a tiny bit. And this time it will be 120 is at 4,755. So it's going to be right in about the middle right there. Okay, so we can kind of see that trend line. Do you see how the dots are going? Now remember, a line graph, we also connect the data points. So I'm going to connect. We could actually start from 0 because at first there was no water being wasted. And I'm going to connect my lines. Sometimes you can use a straight edge, like you could take a straight line and help you make the line even straighter, or something that's straight. So we've just created a line graph, and what we can see here is that it's a pretty steady amount when we leave the water running. We could actually use that. Whoops, I missed that part, didn't I? We can use the line to help us make predictions, or we can use our line graph to help us make predictions about how much water we would spend. So for example, we can see that's a pretty straight trend. So we might think, okay, well, what if I brushed my teeth twice a day? How much would I waste? And what if everybody in my family was wasting water like this? Then how far would this go, and how much water would we waste as a family? Okay, let's go back. And now you're going to go to a website that provides weather information, and you're going to choose any place in the world that you would like to travel to and look at their 10-day forecast from today. You can look at the dates and record what the next 10 days would be. Then you can take that information to a graph. Now the temperature for this one was recorded in Celsius, but typically in the United States we use Fahrenheit for temperature, so you may want to use Fahrenheit instead of Celsius, but you'll need to remember to think about what your scale should be, or what you should be or how you should be counting on your graph to make sure that you have the correct range for your graph. And at the bottom you can put the dates, like see this has March 14th, March 15th. You can either put the dates or you could put the days of the week, but you probably need the dates because if you do it for 10 days it's going to go past a single week. And so the time that you're going to be using for your graph would be days of the week, and your y-axis is going to be temperatures. You need to remember to plot the point for each day, and then to connect using a line once you've plotted the point. You want to make sure you put a nice title on your graph as well. There are directions for completing this task included in Canvas for you. Thank you.